Hi. Can you hear me?
Yes,
can you hear me?
you. Yes.
Oh, yes,
Okay.
yes. It's okay. Okay.
Now it's
Okay.
perfectly fine.
Okay. We're sorry for the
No worries.
for the problem. Just a second.
Okay.
All right. It is working. Yes. Yeah.
Thank you so much.
Okay. We can open the camera.
Thank you so much.
All right. I'm a Professor Mihi Kim. I come from South Korea, Hamgyong National University. This session we have for first presenter is not here. So what about second presenter? Sir. No? No. All right. Hello. Are you a presenter? No. No. We are waiting for first presenter a little. So after he coming, we'll start.
Actually, first presenter is best person. I can really.
Okay.
Are we slated for first presenter?
No.
I'm sorry.
Yeah. There is no first presenter. I don't know.
Okay.
Yeah.
No, it's okay.
I don't know he is coming or not. So should we be waiting for him or him?
No, we can
No?
continue with the
No,
other.
okay. Okay. maybe there is no first presenter. So what about start to present your paper second? Because first presenter is here.
Okay, okay. I
Okay.
understand. Okay. I'm sure. Yeah, but I can see. Yeah, just I guess like wow. They are really very like like that.
Mm-hmm.
Because there are really like that. So I can't switch. Okay.
And let's start with the other presentation, then we will
Okay. Okay.
Okay. Second presenter has some problem on presentation. So what about start to first Madi?
Sure, I can start presentation. Do you hear me? Yeah, can you hear me?
Madi?
Yes, I can hear you.
Are you hear me?
Can you hear me?
Hello?
start sharing the screen.
Can you hear me?
Okay, but this is not wrong.
I stop. But
Okay.
Yeah. Okay.
Can you see my screen? So can you see my screen? Should I start? I don't know. I cannot hear you. You are mute now. You can use chat if you want to tell me something. Okay, perfect. So I start my presentation. Hello, everyone. Unfortunately, I cannot see you. Okay, but anyway, my name is Mahdi Zari. I'm from Tecnológico de Monterrey, in Mexico, and today I'm going to talk to you about my paper, which entitled DRHRP, a deep reinforcement learning-based hybrid routing protocol for UAV-enabled wireless networks. So before I start my topic, I want to tell you a little bit about basically my university. As I mentioned, my university I'm from Mexico. So the University Tecnológico de Monterrey is located in Monterrey region. Basically, it's the base in Monterrey region, north of the Mexico, but we have several campuses across basically Mexico. So I want to give you just a little bit of context. The picture that you can see is the main campus. It's really beautiful. The university rank about last I checked it was 185 in the QS World Ranking. In the computer science, in particular, we are ranked at the top 100 universities in the world. And we have, as I mentioned, we have 26 campuses across the Mexico, which basically serving about 90,000 students. So I just wanted to give you a little bit of context about my university, where I'm coming from, and where I'm basically doing the presentation. Right now, it's about 5:30 a.m. in Mexico. So we know that recent years we see basically rapid growth of UAV application, unmanned aerial vehicle applications, all the way from disaster recovery, from, for example, precision agricultures. As I mentioned, disaster recovery is where, for example, after a disaster, we start using how to say these UAVs for searching for, let's say, live people. So there are so many different applications, all the way from military application to basically uh, agriculture applications. So there are so many different basic applications. And now the last many years, last couple of years, I can say we can see more and more usage of it. So unlike, let's say, conventional mobile ad hoc network or managed flying ad hoc network, introduce some new challenges because for their characteristics, because the drones, okay, or these unmanned aerial vehicle can fly into the three-dimensional space, okay, and the rapid change of their topology, they introduce new set of challenges that we couldn't see in, let's say, traditional or in mobile ad hoc network. And also another challenge that we can see is energy limitation of these flying, say,
No.
vehicles. So these challenges basically, as I mentioned, is different. So, for example, because of this three-dimensional moving space, so we can observe frequent link breaks, which can cause high delay and high packet loss in the communication. Also, because they're flying, so they consume a lot of power and a lot of energy. So, and because they need to be lightweight, so they have a limited onboard energy. So everything that we work with this flying ad hoc network should be really energy efficient. So another thing I want to highlight in this research is a trade-off between proactive versus reactive routing protocol, which we are focused on this one. In talking about basically, for example, proactive routing approaches can incur how to say, high control overhead, because they are constantly basically doing route discovery and doing a lot of things. Okay, so it can cause a lot of overhead and can cause, of course, a lot of energy consumption. On the other hand, purely reactive, let's say, approaches, they can suffer from, let's say, route discovery delays because they're waiting for the certain time to perform their action so they can. So each approach can have its own problems. So basically, what we try to do to address these basically interrelated challenges, okay, let's say in a central manner, okay, to basically to achieve, let's say, low latency energy aware communication in this flying ad hoc networks. So the objective of research was, of course, to maximize packet delivery ratio, like any other communication protocol or routing protocol. Another objective is to minimize end-to-end delay. Basically, these are the things that we are trying to approach while basically this maximizing PDR, minimizing delay, while we are conserving energy and, of course, we're reducing control overhead. So basically, we try to do this, achieve this these various objectives. Okay, and we did some experimentation, some simulation with varying densities of these flying ad hoc networks with varying the speed and beacon intervals to see how these changes can affect the performance of uh, our routing protocols. So So basically, what we did, we modeled this flying ad hoc network as a dynamic graph, okay, where each basically vertexes represented a UAV and each edge represent a wireless link between these UAVs. So every UAV periodically broadcasts beacon, okay, that contains various information like GPS coordinate, residual energy, queuing status of this particular UAV, and these beacons are basically transmitted periodically to other UAVs. Also, link quality between UAVs, okay, for example, an I and J is UAV I and J is estimated using, let's say, FNO, signal-to-noise ratio, and also frame error rate, okay. And then the distance, the Euclidean distance between I and J, also calculated in this equation. So basically, the various local state, okay. Uh, then we use these various local states in our reinforcement learning formulation to achieve the objective that we were looking for. So So basically, we model the routing as a Markov decision process, okay, where we have states, okay, state S, which basically encapsulate each UAV's local information that it has from the neighbors, for example, such as their neighbor links, such as link qualities, energy, Q lengths, and all those information in that state. Then we have action A's, which are selecting the next hop neighbors. Okay, basically we have all this state. Then we have the action is which next hop we should choose between all the neighbors that we might encounter. Then we have the reward, okay, which is basically designed as a weighted combination of the PDR, packet delivery ratio, delay, and energy availability for that UAVs. That's how we basically formulate it. So basically, we try to balance this delivery success, latency, and energy consumption using this formulation. So the final goal, basically, the actual goal is to somehow learn a policy, okay, that can maximize the expected cumulative rewards over the time using our basically DRS Sharpie routing protocol. So it's, as I mentioned, basically the title define it's a hybrid routing protocol. So it's both proactive. It does proactive neighbor discovery and reactive, basically deep reinforcement learning forwarding. So as I mentioned in introduction somehow, that going pure proactive then has its own problem. Going pure reactive has its own problem. Hybriding this can somehow achieve a better solution. So basically each basically UAV act as an independent agent in a multi-agent setup. So, and then using these beacons that send periodically, we send basically information to each UAV send information to update its local state. When a packet arrives, then the UAV start and invokes its deep reinforcement learning policy to choose the optimal next hop, and so on and so forth till the packet arrives to the final destination. As I mentioned, because it's flying ad hoc network, so it can has just so many different challenges. So this combination of basically proactive and reactive approaches can somehow ensure a, each time a fresh topology awareness between each UAVs, okay, without incurring excessive control traffic for those sensors. So we tested our let's see if you can continue. Yeah. So okay, so we tested basically our program, our algorithm using the simple network simulators setup. We run it each algorithm for 500. We run the algorithm for 500 rounds. As you can see here, the simulation basically parameters. So we used 50 UAVs, and then we start varying it, basically 50, 100, 200. Simulation area was one basically cubic kilometers, because it's a three-dimensional. As I mentioned, when we are talking about flying ad hoc network, it's not just two-dimensional like MANET, it's a three-dimensional. So the mobility model was Gaussian Markov. The speed was I said here 100 kilometers per hour, but actually we varied it and to also see the effect of speed on the performance. Beacon interval also varied, but the default was set to half a second. Transmission range of each UAV was set to 250 meters, and so on and so forth. So, and also the metric that we measured was the packet delivery ratio, delay, energy, and basically overhead. So the first study that we did, basically, this is the result that we got. As you can see, what we did in the first, let's say, round of simulation, we varied the number of the nodes from in this simulation I'm presenting here from 30, 50 to 100, which basically can represent how to say, a scarce network, okay, to, let's say, all the way to normal network and, let's say, dense network. So we try to study the node density variation effect on the performance. As you can see from the result, our HRP basically consistently achieving a better packet delivery ratio, usually always basically above 90%, even at the high densities like 100 nodes. Okay, and as you can see, and when delays is below 35 milliseconds, and if we are somehow comparing, we compared basically our algorithm to some benchmark protocol like HRB and HER. As you can see, the HRP improves PDR by 8%. It might not sound so much, it's a little bit, but it's still it's something. And also the delay reduced by 15 milliseconds. I really basically this achieved using this hybrid approach with basically deep reinforcement learning in a let's say in a reactive fashion. So we also did another study. We changed basically, we varied the speed from 100 to 200 kilometers per hour for each particular UAVs. So we tried to see how the variation of the mobility speed or basically the dynamic of the network can affect the performance of our algorithm. As you can see, when you increase the speed, of course, you can incur more link breakage. Basically, all these UAVs are moving faster around, so the links are connecting and disconnecting much faster. Of course, in this experiment, the number of UAV was set to 100. It's a dense network, so we could see a lot of connection in all the time, but those connections were broken constantly. So this under, for example, the extreme mobility, as you can see, under 200 kilometers per hour, DHRP, DRHRP maintain an 85% PDR. Of course, it's much less than the earlier experiment that I show you, because the movement is so much. So a lot of those movement and link breakage cause packet drops. But still we perform slightly better than, for example, benchmark algorithm like HER by 5%, and also we reduce delay by 5 milliseconds. Okay, so this is basically this was in the mobility speed variation. Also we did, I'm sorry, I think. Okay, yeah. Also, we varied beacon intervals from half a second to 1 second to 2 seconds, as to see how this variation in the updates that UAV is sending between them can affect the performance of our algorithm. So we can see, for example, when beacon intervals is stretched all the way to 2 seconds, our algorithm basically we will believe that this adaptive policy that our algorithm has can compensate for this sparser topology update, achieving somehow an 89% PDR at a moderate overhead increase, as you can see from the result. So this basically, we believe this result can show our algorithm is also resilience to this fast movement and also various update rates, as it can be seen with the beacon interval variation. So to summarize, to sum up, I know it's somehow a simplified version of what we have in the paper. I hope you can go back to the paper and check it out. Of course, there are a little bit more details, or you contact us for more information. So to basically conclude, we see that our algorithm combine this proactive and reactive approach using a hybrid routing. It's not, of course, a new approach. Hybrid routing has been studied for many years. Okay, but I believe using this metrics and this approach to bring in this deep reinforcement learning, we could do some basically achieve a better PDR, reduce delay and energy. So the algorithm validated using a simulation result. Of course, it's not so valid when you use purely simulation, but in the next stage, if basically we continue this work, we want to do some pilot tests using, let's say, 20 UAVs that we have in our labs to try to see how it's really affect in a real, let's say, UAV, if we implement some solution like this, not just a simulation, but doing actual experiment. So as I mentioned, in the future, that's the future basically work that we plan to do using real experimentation. And if in the future we can get the hands on more UAVs in my lab, then we can do, of course, much larger experiment and larger the swarm to see how we can basically achieve that. So thank you so much for time and for hearing my talk. I'm available for any question that you might have. I cannot hear you. I think you're mute. So. Oh, still I don't have the sound. I'm sorry. I cannot hear you. I can see you're talking, but I cannot just hear you. If you can type, I can try to answer any question that might have. Okay, thank you for the question. I just see that you're typing. I was waiting for it. So the most important contribution, as I mentioned, I don't want to basically glorify this work. It's like I know there are so many routing algorithms out there, so many different things. Okay, so but it's still this working. I mean, most of the, let's say, routings are working on IoT devices, manets, VANETs, so many things. Okay, I think it's still for there are so many work. If you do the literature review, you can see there are so many works around the FANET, right, flying ad hoc networks. But it's still, I would say, it's less touched comparing to other areas that has been massively studied. So to answer this more precisely, I would say this bringing basically this deep reinforcement learning in a lightweight manner to, let's say, to FANET. Okay, I would say that that was, again, I would say, not really like a novel idea, but I think the way that we did it, the way that we formulated, we could achieve a little bit better result. As you can see, the result that we achieve is not massively different with the existing work. I think it can be improved, but maybe I can say that as a main contribution to the formulation of the problem and the way that we use basically hybrid routing, bringing both proactive and reactive approach using deep reinforcement learning. But as I mentioned, the work is stayed in a simulation phase for now. But as I mentioned, but the idea is to do the real test to see it's because when we do simulation, of course, we all know that it's much simplified. In real world application, you see so many different variables that you cannot simplify or simply consider in simulation. So what we hope is to achieve more or less the same set of results, same better improvement to some extent. Okay, to see, okay, it's working to somehow, so we can start doing it better, or we can improve it. Okay, so I wouldn't get so much excited until it's in the simulation phase. But if we get the better things in a real test bed, in a real world application, in a real world basically implementation, then I can be more excited to see better results in even if it's like just couple of percentage of improvement is still in a actual implementation. That means a lot comparing to just a simulation. I hope I answered that question somehow. I don't know if there is anything else. Okay, thank you so much. Thank you so much. I'll stick around to hear other presentation. I stop sharing.
But it's working, I guess.
I connected in my hotspot.
Hello.
Can you hear us?
Can you hear us, anyone?
Just a second. You continue to speak. I'll ask an online colleague.
You can just open the YouTube stream to see if you can.
But it shows that we are
Actually-
using the microphone. Even there, it shows
Yeah,
that we are talking.
Blue
Yeah.
framework.
Is anyone there?
I don't
No, anyone. No one. Just Mehdi. Just Mehdi.
Hi, Mehdi. Can you hear us?
I don't know if it's just Mehdi. Maybe we can-
Yes, I can hear you.
To us on the YouTube stream.
Okay.
No, he said no.
He says that he can hear you, but with a very low volume.
Yes, I can
Do
hear
you
you.
hear us? What?
Çok kısık bir sesle seni duyabiliyorlar.
Wow.
Okay, go ahead.
So
Okay.
if you speak loud,
Yeah, okay.
it will be okay.
Okay.
Thank you.
Okay, I guess screen share it. Okay. Hello, everyone. Thank you for again. I will present our short survey leveraging large language models for natural language processing based tasks in the legal domain. A short survey. Actually, I am from Yavuz Baba from Ege University, and this work was conducted together with Birol Çilloğlu. Here is the outline of the presentation. I will briefly introduce the topics, review previous work in legal NLP, discuss key challenge and task, present how LLMs are being applied, explore data and evaluation strategies. Actually, okay. And conclude with insight and future directions. Legal tasks are very long, complex, and full domain specific language, making them hard to process. Actually, even for the legal professional. But with the rise of large language model in like GPT-3, we have seen impressive improvement in the understanding, semantic, and contextual depth of such text. As a result, LLMs are now being widely explored for tasks like classification, information extraction, information retrieval, legal judgment prediction, and summarizations. A growing body of research has focused on applying NLP techniques at the legal domain. From early rule-based and deep learning-based approach to today's LLM-powered solutions. These studies have tackled core tasks such as information retrieval and I said. We separated the paper according to LLM-based and non-LLM-based approach. Non-LLM-based approach contain different methods, which rule-based or machine learning or deep learning or another this method approach. We reviewed a total 19 studies. 10 of them focused on LLM based approach, while 9 were based on other methods. The studies were published between 2018 and 2025. You can see the distribution by publication here in the first chart. We tried to include the most recent and relevant works as much as possible. When the studies are examined, there are 5 key tasks where challenge persons: classification, information retrieval, summarization, information extraction, and legal judgment prediction. Actually, maybe you can examine meaning of papers. We group the challenge into 5 main tasks commonly addressed by legal NLP research: classification, information retrieval. Classification identify the type of legal documents topics. Information retrieval find the relevant case or legal domain legal documents. Summarization reduces lengthy documents into case or legal document. Summarize for easily analyze legal case. Information extraction, pulling out to key legal facts such as parties of dates. Legal judgment prediction, forecasted court outcomes based on textual evidence. Each of these tasks requires not just language understanding but also domain-specific reasoning. Alarm shows strong performance on legal NLP even with limited level data thanks to their zero and few-shot capabilities of other LM techniques. But they are not perfect. Actually, hallucinations remain a serious issue, especially when incorrect legal content is generated. Domain-specific fine-tuning helps, and interpretability is increasingly becoming a design priority. Legal specific fine-tuning self-model better aligned with the prices, language, and logic of the field. Recent research also explores integrating external tools like the retrieval automatic generation, like to grant responsibly verified legal documents. Oh, actually, I can't handle it.
Belki küçük şeylerden gösterebilirsin o zaman ilerler. Full screen olunca ilerlemiyor.
Wow.
Because the problem with the presentation, they were still seeing the first slide of the presentation, the title
Okay.
online. Messages that
Maybe now they can see. Okay. However, LLMs are not without limitation. I say that begin. One of the biggest concerns is hallucinations, generating output and different or not wanted outcomes. That's why many studies now focus on improving interpretability and transparency. Data for legal LM training or testing or evaluation, multiple data that exist. The Cambridge Law Corpus for English, COLI and Scale 2018 and for Chinese, and other custom data or annotated data, maybe according to Italian or English. As can be seen, the dataset are predominantly weightedly English or Chinese. However, the availability of high quality multilingual legal corpora remain bottleneck. Legal analysis require require task specific evaluation because of the machine learning techniques. I'll just generate an outcome textual, but tasks summarizations or information extraction, just a task and require task specific evaluation strategy. While standard methods like accuracy and F1 score provide baseline, they often fail to capture legal reasoning. Semantic aware metric like bar score along with actually human evaluation strategies are essential. Also, hallucination is now being treated as a key axis of evaluations. Although powerful, they struggle with the specificity and precision that legal applications demand. Most are trained on English data, which limit performance in the other language. And also hallucination and lack of interpretability are still major barriers. To address these methods like the domain-specific fine-tuned and retrieval augmentation generations increased to increase hallucinations are being developed, but human evaluation remain critical because of the evaluating hallucination is so difficult scenarios and issue. In conclusions, LLMs have shown great promise for legal NLP tasks, particularly where deep understanding is required. Fine-tuned models significantly outperform from general model. However, trust and applicability are limited by hallucination and lack of interpretability, bias, and issue. To build reliable legal AI systems, we need better dataset, clear benchmark, and a strong evaluation framework. Especially, how can evaluate hallucination? How can evaluate interpretability? This is main issue for LLMs, especially in the legal domain, because legal domain is so critical area for the interpretability. Sorry. Thank you for your attentions. I will be happy to take any questions you may have. Yeah.
Based on your review, what's the best metric?
Sorry.
Based on your review, what's the best metric to evaluate this model?
Actually, I can say human evaluating is so critical because another metrics for evaluations.
Yeah.
Yeah, another metrics and analytic data and many researchers accept any annotated textual, meaningful textual data. So LLMs maybe generate true concept, true meaningful generate outcomes, but another metric, bar score or another F1 scores is not correctly evaluate generating score. So human evaluation is so critical role LLMs when I examine researching literature. What?
It takes so much time to evaluate.
I can.
It takes so much time to evaluate when human wants to evaluate.
I can understand. Sorry.
When a human wants to evaluate this model, it takes more time.
Yeah, more
Because
time.
you
So
have to generate, you have to ask
Yeah.
the question, receive
Yeah.
the answer, then
yeah,
based
yeah.
on your judgment.
Yeah, you're right. We have we need to benchmark our evaluation strategies, hallucinations, evaluate hallucinations and interpretability. Nowadays, bad score or F1 score enough cannot enough for evaluate LLMs. Human evaluation is so consume for timing or human resources. Yeah, you're right. But F1 scores cannot enough for LLMs. Maybe we develop new evaluating strategies or evaluation methods. I don't know. This is gap for research area to evaluate LLMs. Uh,
Thanks.
Thank you.
So is there any question?
Thank you for listening. So.
Thank you. All right. Originally, we have 5 papers for presentation, but unfortunately, we have only 2 presenters in this session. Okay.
3 no show.
Yeah.
One virtual, one presence. Only the second and the third was present.
Yes.
Yeah, I came here for
Course,
this
yeah.
element point to be.
No one.
This one was interesting for me. This was my opinion, but it's fine to me.
So no one?
No one. Yeah. Finish. Okay.
Sorry,
Let's finish.
I'm in this link. I have this link for evaluation.
Actually, we
And
satisfied
please mark
to
someone
give
who
a
are
West
absent.
graphical concept and beautiful neural technique, another method,
Thank you for your question.
complex but nowadays there aren't acceptable relationships for
We had a student, and then he was moving with this right.
Black method.
Yeah.
Black method.
I have attended
Evaluate the
the
model, but
several
none of
times
the
in
metric makes sense.
ICCSA conference,
Yeah,
but
Because the
this
answer was
year there's a lot of problem.
not
Yeah.
but the
I don't know
score was
why.
very high.
First
Yeah.
of all, we have
But
very
black method is another concept and
Yeah,
in there
Is there any secret for
Yeah, sure, but we
Yeah.
wanted to find the metric to evaluate this
Because,
the
yeah.
answer.
Today I know I'm a chair
Yeah.
in this session. Yeah. Nobody let me know.
just
Then,
researchers
yeah,
let
we
the
start
drug
as chairs.
recruitment
I asked
site,
to
MRR
Professor
score or
Osvaldo, but
true
he didn't answer about
And
that.
another site allows
Nice to meet you.
generate outputs to
So what
evaluate
is your research saying?
this two methods separated not together related. So this is so complex because allows reasoning. How can we evaluate the reasoning? Because
Yeah, I will
the
just take a
strategies
picture
to improve strategy, labeled data, emitted data, or summarization, score or token based
I just
scores
remember.
for the sorry.
Thank you.
So allows this new get a new concept.
Yeah.
So how can we relate to reasoning strategy? I don't know.
Thank you.
Everything that will go to the room
Yeah, I also
Aslında yaşadık zamanlarında orada.
Güzel.
Most
Pratik şey yani karakter konuşmasını anlamak bilmiyorsunuz.
So are
You need a third copy.
Yes.
yeah.
For how long?
Just take a coffee and.
Yeah. We are here for like maybe 10 minutes.
Thanks.
But in general, is it safe to leave?
I think it's safe. I mean, because they're all like conference attendance.
Maybe it's better if I use mine. Here, the camera doesn't work. Hello. Do you listen to me? Do you listen to me? Are you here?
Yes.
Yes. Oh, fantastic. Now I can listen to you. I'm sorry, the connection is not so good, so...
Okay.
I didn't succeed to switch on the camera. 1 second, I'll try to try. Just to understand if all people are here. Mana Dastum is here. Matteo Zucca, Flavio Stocchino, Mario Lucio Pupi, Giovanna Concu, are you there? Yes, I can see you.
Yes, Giovanna and Marco.
Okay. Marco, show yourself. Just for say you hello. Is not here, Marco?
Yes.
I can see. Oh, okay. Don't worry. The connection is not so good. Apostolos, Lagarias, Avrili, Lecca, Dionisia, Kutsi, Anastasia, Strategea, are you there?
Krivileka, yes.
I'm sorry. I'm sorry for my really bad pronunciation.
It is okay. Thank you.
And
I'm the second on the row, so
okay. And again, Giovanna Concu, Federica Lecca, Costantino, Carlo Mastino, and Daniele Meloni.
yes, Giovanna.
The last but not the least. So I think Teresa Guarda is here. Teresa Guarda? No. Okay. So I don't know if you, Mana, if you want to start this section, because the first one is not here. So I'll give you the floor to Mana Dastum. She will present a paper entitled Developing a Methodological Framework to Assess Social Equity to Regional Spaces Through the Lens of Space Syntax. And Mana, the floor is yours. I don't know if you succeeded to present yourself. My computer doesn't work, so try to do like this. Okay, I'm trying to share my screen. Okay. But this is not mine. I'm sorry. Ask if they can see your screen now. No, I'm not sharing it. Okay. Okay. Can you see my screen?
No.
No.
There will be a delay again.
No.
Okay. You have to share. You have a link, man, because you can send to me and you can show here. Do you have a link? Ah.
Please don't use the full screen presentation mode because it was stuck at the first slide in the previous session.
Online it was like offline you could just see the slide.
We will try.
But it's not shared.
Now can you see?
No.
Still not.
Can you see my screen?
No, no.
No.
Maybe you should rejoin.
You can show us that it's not shared.
I'll try to. Okay, 1 second. Doesn't work your pen drive. But maybe I have your.
You know the rest of the right option is showing the full screen. The middle one is showing choosing one specific.
Which one? This one? And here.
You should choose the last one, which is full screen.
Third option.
For sharing. Okay.
Yeah, the third option is
Tam means full in Turkish.
yeah.
Full screen. Can you choose the third option?
The third option.
Tam.
Can you see? So, yeah, it's now we can see with my.
Yes.
Okay. Sorry. Okay.
This chat box.
Okay. You can use this one. Okay.
Close the chat.
Oh yes, I can. Yes.
Okay.
Hello everyone. Thank you for giving me the opportunity of presenting our research. The title of our research is Developing a Methodological Framework to Assess Social Equity in Regional Spaces Through the Lens of Space Index. Please let me introduce a bit ourselves a bit more. We are a research team consist of professors and postdoctoral researchers at the University of Cagliari. Our areas of expertise are smart cities and communities, sustainable mobility, space impacts, and social equity. And our supervisor is Professor Chiara Garau, and we are doing many research under her supervision. And the presentation is structured as follows. First, introduction, where I can give you an introductory explanation of social equity, space impacts, identifying research gaps, research objective, and research questions. Followed by material and methods, then finding and results were represent a general overview of existing literature, social equity indicators, and specific metrics. And finally, the conclusion, which proposing a new methodological framework to link social equity and space impact theory. Now I'm going to tell you a bit more about social equity. What is social equity in urban and regional planning? Um, Actually, social equity is a fundamental principle of sustainable urban development, emphasizing the fair distribution of resources, services, opportunities to all individuals, regardless of their socioeconomic or demographic characteristics. Social equity in urban planning has several features, including accessibility to essential services, connectivity within and between communities, inclusion of diverse social groups, personal safety and security, and finally, equitable allocations of public amenities. Now, I would like to ask you a question. Have you ever think about the difference between social equity and social equality? Do you think these concepts are the same? Um, this is social equality, which provides the same solutions for everyone. And this is social, social equity, which focuses on addressing specific needs and overcoming systematic barriers into inclusion. So they are not the same, they are different concepts. Um, Social equity in urban spaces can promote social-spatial structure, economic opportunities, social cohesion, and quality of life. On the other hand, um, space syntax, which is a theory in urban planning, argues that the configuration of urban grid itself is the main generator of movement and social encounters. It offers quantitative insight to assess how urban layers affect accessibility, connectivity, and inclusivity. Accessibility measures how a spatial configuration facilitates or restricts movement within urban spaces. Connectivity to understand how well different areas are interconnected. And inclusivity assesses the equitable distribution of public and green space through visibility graph analysis. Despite the evidence aligned between indicators of social equity and the analytical tools provided by space syntax, the integration of these two domains remains largely unexplored. Space syntax has been extensively applied to study spatial accessibility, as you can see here, inclusivity, and connectivity. However, its potential to address the broader and multidimensional concept of social equity has not yet been fully realized. Thus, this research aims to develop a methodological framework that integrates space syntax analysis with the social-spatial dimensions of social equity to address this gap. Based on this assumption, the following research questions are proposed to seek suitable solutions. From a social-spatial viewpoint, what are the key factors of social equity, and how can they be operationalized within the context of space syntax analysis? 2. How may the combination of space syntax metrics with the social equity factors reveal new insight into spatial patterns? And finally, what methodological framework may be developed to systematically connect space syntax analysis with the different aspects of social equity? This research has a significant insight for both the theoretical and practical points of view. It offers a new theoretical framework for researchers, goes beyond theoretical accessibility measures, provides practical insights for planners, And finally, the results may guide the design of more equitable cities. This research, by contributing to the reduction of spatial segregation and promoting inclusivity, contributes to achieving three sustainable development goals: 5. Gender equality, 10. Reduce inequalities, and 11. Sustainable cities and communities. The research methodology in this study is a quantitative approach, and the visual presentation of research methodology presents here, and as you can see, it has five key steps. Step one is general overview of the relevant literature. Step two is identifying the relevant indicators of social equity. 3 is reviewing the space syntax metrics. 4 is linking social equity indicators to space syntax metrics. And finally, step 5 is the constructing the proposed methodological framework. A keyword search strategy was conducted through the Scopus database to identify relevant studies. By a set of accurate keywords including accessibility, social equity, urban and regional spaces, and space syntax. In the first search, we only found 4 records, which 3 of them were not fully relevant to the literature. So we dropped space syntax and repeated this search again. In this stage, we found more than 400 research. It shows that the combination of space syntax analysis with the social equity assessment has not been fully realized now. And here you can see the systematic review flow diagram. As you can see, it is categorized into 4 sections: identification, screening, eligibility, and inclusion. These 448 identified reports by applying the search criteria such as language, subject area, and document type limitation, and screening reduced to the number of 19 records. And finally, the number of 19 records will remain in the study. In this table, you can see the other closely related concept to social equity. In order to avoid missing any single research, we considered all these related concepts, including spatial justice, inclusivity, equitable access, and social fairness. And this is a workload visualization. It presents a quick overview of the prominent themes. The notable absence of space syntax in this keyword shows that it also shows that the combination of these two theories has not been fully understood and need to be investigated. Since the focus of this study is developing a methodological framework, we only extract, analyze, and categorize the methodology employed in these identified studies. Here you can see a heat map that using the frequency of research method with a color gradient from dark blue indicating lower frequency, to bright green, indicating higher frequency. It shows that GIS-based spatial analysis is the most frequent used method in this study, followed by equity measurements like Gini coefficient and Lorentz curve. It also indicates that space syntax is among the uh, least frequently used method in the study. Um, this table shows the social equity indicators extracted from the reviewed literature and their definitions. Accessibility, which means ability to reach, enter, and use space services and opportunities. Inclusivity, to ensure equitable access, participation, and representation for all people. Fair distribution of amenities means equitable dispersion of essential services, and security means safe, crime-free, and socially protective environments for all. On the other hand, space syntax has several measures and metrics that have been used in different studies. But the initial reviews indicates that the four classic space syntax metrics, including integration, connectivity, and choice and control, are the most commonly used metrics for investigating social behaviors. In conclusion, um, hopefully we obtained a very attractive outcome in our research. This image visualizes the theoretical framework to integrate space syntax metrics with social equity indicators and its methodological procedures. Based on the reviewed literature and both theories, this research identifies a specific space syntax metrics for each social equity indicators, including accessibility, inclusivity, equitable distribution of public facilities, and security. Regarding accessibility, the appropriate metrics depends on the scale of the analysis. Local scale use connectivity, while regional scale use global integration.
The final sentence.
Okay. For measuring inclusivity, we use integration, connectivity, and choice metrics of space syntax combining with empirical observation, and also integrating this analysis with universal design help to promote um, mm, accessibility for people with disability. Equitable distribution of public facilities like green spaces and urban spaces can be evaluated by space syntax metrics, namely integration combined with GIS-based land use measures. And moreover, economic measures like Gini coefficient or Lorentz curve should be integrated with this analysis in order to understand, in order to help understand the distribution of services, how impact the population. And finally, security can be assessed through several space syntax metrics, including integrity and connectivity. And also, it should be integrated with choice and control. And also we can combine them with visibility graph analysis, and moreover, for the subjective measures of security, we can integrate crime prevention through environmental design surveys to fully to be able to fully assess the security. Um, in summary, we developed a methodological framework to integrate space types analysis with the social-spatial, with the multidimensional aspect of social equity. And depending on the concept and the scale of the research, we can use this theoretical framework to ensure that to ensure that we can assess all dimensions of social equity. And as you can see, all the research questions have been properly answered in this study. Okay, and since then, um, okay. Since the focus of this study is developing a methodological framework for the orientation of future studies, which suggests to work on the practical aspects of this issue, and in our upcoming research, we combine this theoretical framework in a practical way, and our upcoming research, which some of them have been already published in journals, and some of them are finalized. And thank you for your attention. And okay. Thank you.
Thank you so much. I am inside with the author, so I have more pressure to finish because I don't want to be the chair and also to be the person that brings so many times. So I'm sorry, but Mana works with me starting from April. From April, it's called
March.
At the end of the March. But she from Iran, for coming in Cagliari, so from April, and we started to this work and. With the theoretical part, and now we can be funny with the practical part of this research. So, okay, do you have any question, or we go ahead with the next speaker? We go ahead. Thank you so much, Mana, and I can call the next speaker. The next speaker is Marco Zucca, Flavio Stocchino, Mario Lucio Puppio, Giovanna Concu. Luckily, with this name, I don't have any kind of mistake with my pronunciation because they are from Sardinia, are my close, how I can say, close colleagues. So the floor is yours. For each speaker, I wanted to underline that each of you has 20 minutes. So, do you listen to me? Are you alive?
Yes.
Okay. Avril is here. Giovanna, Marco?
Yes, Chiara, Marco has some problems, so maybe we can switch, and after Akrivi, I can give my presentation, if you agree.
Yes.
Okay.
We can organize our, we think it's the best one. So organize yourself. You have two presentations. If you want, you can present your last. So the first is yours.
So, Akrivi, it's your...
Okay. I will make the presentation now.
Okay, go ahead.
Whatever you want. I can wait.
Just Avril, I will introduce you. Just the title.
Okay.
Linking tourism hotspots and vulnerability to climate change. Case study Rhodes Island, Greece. So the first is yours.
Thank you very much. I will close my camera in order not to overload the network. That's why I did before you presented the other colleagues. And I will try to keep the program and the time. And now I will share my presentation.
Okay, we can see your presentation.
Thank you so much. So I am Akrivi Leka, and together with Apostolos Lagarias, Dionysia Koutsi, and Anastasia Stratigea, we did this paper that concerning the linking between tourism hotspots and the vulnerable climate change areas. The case study is Rhodes Island. It's an island situated in Dodecanese complex in Aegean Sea.
Avrili, we can see we see always the first slide. I don't know if you are speaking.
No, I didn't change. I am still in the first.
I'm sorry.
You
can use a slideshow.
You can use the slide show, because in this way we can see your presentation in all its beauty.
So you don't see the slideshow, eh?
No, we can see like the modality to fix something.
Okay. I am using the slideshow to my PC.
Okay, don't worry. Go ahead.
No, it's okay. Can you see now the same?
It's the same. Don't worry. Go ahead.
Oh, okay. Maybe there is something I have to. Just a second. Okay. Just let me try to do this again. Anyway, okay. In order not to delay, so now the over-tourism is a common phenomenon in Mediterranean insular territories. And here we see some significant examples, especially, let's see, Santorini in Greece. It is a crowded site, enjoying the Cycladic architecture. Also, we see an overloaded coastline in Cyprus, the same in Sardinia, and another example in Spain with a crowded beach beside the natural protected area. On the one hand, we have Mediterranean, that it is a tourism hotspot, and on the other hand, we have Mediterranean, who is vulnerable to climate change risks with warmer summers, depletion of water resources, loss of biodiversity and loss of marine biodiversity, and increasement of diseases. So tourism is a very important pillar for local development in Mediterranean insular territories, but also it is a main source of degradation of the natural and cultural resources because it exposed tourism destination to severe pressures as water stresses, energy stresses, urban sprawl, etc. The intense tourism activity can cause also a coastal population pressure. There are conflicts over the coastal space, and the dense tourism development can enhance climate change risks to the specific areas. The built-up coastal areas are highly exposed to all those severe climate change events, such floods, and all those events generate also multiple social and economic pressures that undermine the overall stability and prosperity of the region. The ultimate goal, of course, is sustainable tourism development. Our methodology uses spatial data analysis and qualitative and quantitative data in order to highlight the exposure of roads, tourism hotspots, to the multiple climate-related threats. The threats for the Rhodes Island is fires and floods. At the beginning, we try to assess the impact of human intervention to the coast part of Rhode Island in order to identify the tourism hotspots, and then to assess the climate change risk zones for supporting policy reaction and, of course, raising the public awareness. So the three keywords is sustainable tourism development, insular territories, climate change risks, under the umbrella of Mediterranean region. And the steps of the methodological framework are those five. Four have already done. And at the step one, we try to have the profile of the study area by gaining an inside information about the social, economic, environmental, and cultural characteristics of the case study area. In the step two, we try to have some tourism dynamics from like tourism density and intensity by use of littoral-based indicators. And we also try to have a mapping by spatial data analysis in order to see and to show the evolution of the coastal construction concerning hotels and Airbnb. And also the ultimate goal is to identify what are the tourism hotspots. But in the step three, we try to map the vulnerable to climate change, especially flood and fire risks zones, and to see if they locate near tourism hotspots. So we examined past events. There are several events in Rhodes Island, from a fire incident that was followed by a flood incident, as is usual. And in the step four, we try to match together the findings from steps 2 and 3, and then to map and the specific types and the levels of those climate-related risks that affect each tourism hotspot. A few words about the tourism dynamics in Rhodes Island concerning the supply, the hotels, the number of rooms, and the number of beds. So we see expand of and an increase of this tourism accommodation during the last decade. And here we see, we try to calculate and to estimate the tourism pressure by using indicators related with tourism intensity and tourism density. Here in that table, we see the position of Rhodes Island in the Dodecanese complex in the Aegean Sea, as I said in the beginning. And it's obvious and significant that the tourism density, the Rhodes Island occupies the higher value in tourism density related with the Dodecanese Island complex. And this reaffirms, in a way, the pressure exerted on the built environment of the island of Rhodes. And the spatial pattern of this built environment is visible here in the map, shows the human settlement layer. So it is across the east part, east coast line, and the east and north part of Rhodes Island. And here we also can see the Natura 2000 network along the island. So it's very interesting to notice that there are some protected areas that are in the coastline. Here we see the pattern of the spatial tourism accommodation concerning the hotels and the Airbnb. They follow similar patterns together with the human settlement layer, as I said
Avril,
before.
Avril, we will see always the third slide.
Oh, I'm sorry. The third slide.
Yeah.
Okay. So that was the third slide.
Now, yes.
That was the fourth. Okay. That was the methodological framework I said before. The steps I analyzed, only the results to show the graphs that they show the tourism accommodation and the expansion and a stable expansion of those tourism accommodation. Here is are the results of the table I was talking about, the higher position of roads in the Deccanese complex. And here are the maps. Now you see the maps, I suppose.
Yeah, now, yes. Yes.
Okay, that was the human settlement, the pattern that follows those construction along the east part and the north part of the island. And here is also the spatial pattern concerning hotels and Airbnb. They're quite similar. And now, concerning the climate change risks, we can see here in the map the flood zones with blue, with red, the burned areas in the incident of fire in 2023, and the Natura. So it's obvious that the combined fire and flood risk, it focuses in the eastern coastal rim of Rhodes Island, and there is the Lindus Peninsula. On this table here, we see percentages of the land within flood zone, built-up areas within flood zone, and all those facilities, tourism facilities within flood zone. So it's also obvious that the eastern island zone is more vulnerable. That's why we will focus on that part because of those four reasons. The first is that it has higher vulnerability to combine flood and fire risk. The second is that there is a less planned character of tourism development and more intense build-up activity and higher environmental vulnerability due to the Natura areas that are also located there. Here we see the NDVI index, so we see the loss of vegetation and the expansion of the construction with those with black. So the critical issues for Rhodes Island are first of all, that there is a vulnerability to floods and wildfires, and there is a higher environmental sensitivity due to the presence of all those Natura 2000 areas across the coastline. Of course, there are unsustainable developmental patterns, especially located in the eastern part, which is less organized in tourism development, and compared with the more developed and organized northern part of the island. There is an intense construction activity, an increase of the artificial land cover that replaces the agricultural and takes also place from nature-based, from vegetation cover. And there are built-up areas within protected areas, and that puts further stress considering also the tourist dens and the population activity within these zones. So concluding, the Rhodes Island is a highly rated mass tourism destination in the Deccanese complex. That's obvious and well known. There are large-scale and tourism developments that continue to consume valuable land. And as I said before, protected areas or agricultural areas, and there are the most tourism hotspots that are located. All those trends are caused by the highly rated position of Rhodes in the global tourism market, the development of new technologies that encourage the concentration of tourism activity on those popular destinations, the reliance on foreign tour operators that doesn't offer the alternative to the local stakeholders to have a more sustainable tourism narrative. And very important is the national policy that has been introduced after Greece's economic recession that support large-scale tourism investments by use of specific planning tools that aim to have a growth-oriented model. Concerning the climate change, Rhodes Island face a big risk of losing important natural features. This includes destruction of forests and tree cover and disappearance of wetlands, and together with coastal erosion and presence of tourism that weakens the island's ability to cope with the future climate-related crisis. So it's obvious that a resilient plan, a more targeted resilient plan is needed, and the spatial planning can play a key role in order to include all those climate change risks in planning process to support sustainability and resilience, and of course can also help to educate and to raise awareness of the local communities in order to reduce vulnerability and to strengthen the local resilience. Thank you very much for your attention, and I'm sorry for any inconvenience caused by my presentation to you.
Don't worry, thank you so much. There are any questions? I have just a curiosity, if I can. Did you think also something about the mass tourism? Yes, you underline different aspects of natural aspect, but I don't know if you think by reading this paper to, I don't know, some practical strategies can help to avoid this mass tourism in this little island, and I think that it's a common problem in a little island like what that you underline this paper.
Yes, this is the fifth step, the measurements that
I'm sorry.
should have been taken in order to this survey to be accomplished. So we are working on some specific literature-based standards to see where is the red flag of let's say the coverage, the percentage of cover of Natura 2000 network. There is a limit. We can say some thresholds. Let me say the thresholds that are beyond that limit. This developmental activity.
Okay, thank you so much. Akrivi, it's good. Akrivi.
Yes, Akrivi.
After the end of your presentation, I did the good pronunciation, and we can go ahead with the next speaker. Giovanna, Marco.
Okay. Yes, here I am.
Okay, fantastic.
Thank you, Chiara. Now I try to share my presentation. Can you see my screen?
Yes, perfectly.
Okay, thank you. So this paper analyzes the problem of BIM interoperability in structural design of existing buildings through the implementation of representative tests and their critical analysis, focusing on the exchange of data between BIM software and structural modeling software. Can you see the second slide?
Yes.
Okay, thank you. And here is the context. Italy has the highest number of homes per capita in Europe, but much of its housing stock is over 40 years old and increasingly obsolete. In Sardinia, over 60% of homes are older than 44 years, and more than 30% are uninhabited. The Green Buildings Directive, the European Green Buildings Directive, will require energy efficiencies upgrades for 2/3 of homes built before 1980. As a result, renovation now accounts for 80% of construction value and 64% of Sardinia's building sector output. However, aging buildings hinder the shift to sustainable construction. Addressing this challenge will require innovative, feasible solutions and better collaboration among stakeholders, supported by improved information management and standardized processes. So, a tool that can offer a control opportunity for buildings' sustainable renovation is Building Information Modeling, BIM, a method for generating and managing information about buildings throughout their life cycle. BIM is a process based on intelligent 3D models that provide stakeholders in the sector with in-depth information and tools to plan, design, construct, and manage buildings and infrastructures more efficiently and reduce their overall costs. The basis of the effectiveness of the BIM approach is the concept of interoperability, a fundamental requirement to facilitate and guarantee the exchange of information between the different software platforms used in the life cycle of a building project. Therefore, it is necessary that the flow of information capable of fully describing the production and management process of the structures is defined in a unified language understandable by the various software platforms involved. This can be done by encoding information in standardized formats such as the IFC, Industry Foundation Classes, a common exchange format defined at international level and continuously evolving. Structural design plays a crucial role in the sustainable renovation of existing buildings, yet it lags behind in adopting BIM due to challenges such as the need for manual input from structural engineers, the complexity of creating accurate calculation models, and difficulties in transferring information between architectural and structural models. A key issue lies in the differing approaches to modeling. Architectural models aim for visual realism, while structural models simplify elements for analysis, leading to inconsistencies in BIM workflows. These challenges are amplified when dealing with existing buildings, which require detailed surveys to accurately reflect their current condition and ensure reliable structural analysis. So this study focuses on evaluating the interoperability between architectural BIM models and structural analysis software. Using a reinforced concrete building typical of Sardinia's building stock, the model was created in 3 commercial BIM platforms, exported in the IFC format, and imported into structural software. The analysis revealed several critical issues during the transition between modeling environments, underlining the need for improved integration and communication between architectural and structural BIM processes. The sample building is a reinforced concrete structure with 2 levels, each framed at 2.95 meters apart and supported by foundations located 1.5 meters below the design level. Each floor includes 6 columns, spaced 5 meters apart, reinforced with longitudinal and transverse steel bars. These columns connect to 3 types of beams, each with specific dimensions and reinforcement, depending on their location and structural role. The foundation system consists of inverted T-beams with reinforcement, ensuring stability and load distribution. The ground floor features a composite slab with hollow cores and screed, while the upper floor is a solid reinforced concrete slab, both including openings for functional purposes. An external staircase, 1 meter wide and spanning a height of 2.95 meters, is constructed with a reinforced inclined slab. It includes detailed reinforcement adapted to the ramp's geometry and connects it to its own foundation systems. The working methodology is structured into 4 main steps. First, a model of the sample building is created using 3 different BIM software tools: Autodesk Revit, Allplan, and Arcline, and then exported in IFC format. Second, the exported model is visualized using Kit Model Viewer, a tool that not only displays the graphical model, but also provides access to object properties and relationships, enabling data analysis and verification before further use. Third, the IFC model is imported into the structural analysis software SeismicAD for further processing. Finally, the process concludes with an analysis of any issues encountered during the export and import of data. And here are the results. The 3D models created with the 3 different BIM softwares were exported in the IFC format and visualized using the Kit Model Viewer. A detailed analysis of the exported elements revealed that Autodesk Revit exports more elements than the other tools. Allplan fails to assign objects to work planes, to proper work planes, and introduces non-existent elements, while Arcline does not support reinforcement as independent elements. When importing the IFC files into the structural software SeismicAD, additional data loss was observed compared to the Kit Model Viewer stage. Several elements were either not converted, incorrectly converted, or unreadable. Although manual correction can be made within SeismicAD, this highlights the limitations in interoperability between BIM and structural software, even for relatively simple building models as this one. This figure summarizes the quality of the model transferred from BIM software to the structural software SeismicAD, highlighting the problems encountered element by element. And it is evident that the BIM modeling softwares used in this study manage some types of data differently. Therefore, the export of such information into the structural software using the IFC files does not occur in a univocal manner. But the major problems are associated with the management of the reinforcing bars of the reinforced concrete elements. From the results, the following consideration can be drawn. First, the use of the various software considered in this study was approached from the point of view of a user without specific experience in BIM modeling. So the modeling, export, and import options were often kept in the default mode of the softwares. The building chosen in this study is a significant and representative of the real estate heritage of Sardinia, but is still a relatively simple building. In the export and import phases of the IFC model, some entities are not read, others are not recognized, or only partially, and others are inserted even though they are not present in the starting model. The major problems are associated with the management of the reinforcing bars. The BIM modeling software used in this study manage some types of data differently, so the export of the information into the structural software does not occur univocally. Let us see now the impact of the study at a regional level. Interoperability in structural engineering is still evolving, but is vital for BIM adoption in Italy and in Sardinia, where much of the infrastructure is outdated. From January 2025, BIM is mandatory for public projects over 2 million euros, though implementation is challenged by digital skill gaps and unclear regulations. Italian National Association of Municipalities has proposed raising the threshold to 4 million euros. Sardinia, with many small contracting bodies, is particularly affected by the problem, having one of the lowest BIM adoption rates, about 10% of the tenders. Nonetheless, initiatives like the Iscola school program, which has promoted BIM since 2017, with dedicated guidelines, represent a best practice worth expanding. And here are the conclusions. This paper investigates the interoperability between 3 BIM software platforms, Autodesk Revit, Alplan, and Arcline, and the structural analysis software Sysmicad, using a case study a reinforced concrete building model typical of Sardinia's existing real estate. The study reveals several critical issues during the model transfer process. Specifically, some entities are not read or only partially recognized during the export and import of data, while others appear in the structural software despite not being present in the original architectural BIM model. The most significant problems concern the handling of the reinforced concrete bars. Additionally, differences in how BIM softwares manage certain data types lead to inconsistent or incomplete information transferred via the IFC files. Although the study is not to point out the individual capabilities of each software, it concludes that interoperability challenges are common across all platforms tested. These interoperability limitations hinder the full potential of BIM in managing public works, especially in Sardinia, where outdated infrastructures and small contracting authorities often face technical and resource constraints. And that's all. Thank you very much for your attention.
Thank you so much, Giovanna. There are any questions from the audience? No, Giovanna, maybe it's better if you go ahead with the next paper and...
I don't know if Marco has succeeded in...
Yes, I'm here.
Oh, okay, perfect. Here is Marco.
After 5 computer change,
You succeed, but maybe you don't give the permission for...
Yes, the problem is the connection of the university, Chiara. It's not possible to see the application for sharing. I don't know because.
I don't know.
This?
You succeed to share your screen?
Yeah.
Okay.
Do you see?
Yeah.
Okay, of course. Okay. Okay, I'm ready to start. Introduce myself. I'm Marco Zucca, and actually I'm assistant professor at University of Cagliari in structural design, and I'm the coordinator of the second level postgraduate master in seismic design of structure at Politecnico di Milano. And the main topic of the presentation is the application of the new Italian bridge guidelines to a stock of existing bridge located in North Sardinia. And this is the outline of the presentation. A brief introduction where the main reasons that have led the Italian Ministry of Sustainable Infrastructure and Mobility to develop new guidelines have been explained. Also considering that in Italy we have a detailed design code useful not only for the design phase of new structure, but this code regulates the way for the evaluation of the structural safety of existing structure as the bridge. And after this, the detailed description of the Italian bridge guidelines is presented considering two classes of attention, structure and foundation, and seismic class of attention. These Italian bridge guidelines have been applied to 10 existing bridge, and for the evaluation of these two class of attention, in order to evaluate the possible critical aspects that characterize this approach, because this is a qualitative approach, not a quantitative approach. This is not the correct way for engineers to evaluate a safety level of existing structure. And if the main question is what is their effectiveness in assessing the safety of the existing bridges? The main reason that have led to develop this guideline is that in Italy, during the last 10 years, we have several collapse of bridges that causes the death of 52 people and the injury of the other 38 people. The most important collapse is related to the well-known Polcevera bridge collapse in Genoa, occurred during the 18 August 2020, that caused 43 deaths. And this slide is possible to see the representation of the collapse of the Pier 9 due to the failure of a concrete tie, and due to incorrect scheduling of maintenance intervention. For this reason, in 2020, the Italian Ministry of Sustainable Infrastructure and Mobility have released these new guidelines for the classification and risk management, safety evaluation, and monitoring of existing bridge. These guidelines are updated in 2022, and it is the current version of these guidelines. These guidelines are based on multi-level approach, developed in 6 different levels, from 0 to 5, that each level is characterized by different activities. The level 0 is a simple census of the structure, is basically is characterized by general information about the location, about the number of span, if is a long span bridge or multi-span bridge, is only general information, not useful to characterize the safety level of the analyzed structure. The level 1 is the most important level of these guidelines because it's based on execution of visual inspections. And this is an important aspect because by means of these guidelines, the Italian ministry forced the management company to carry out the visual inspections. And these visual inspections are useful to define the defectiveness levels of the structure by means a particular form, one form for each structural elements that characterize the bridge, that involve only the type of defect, but also the importance grade, the extension, and the relative intensity. And we have a form for a pile, a form for a beam, a form for foundation. For each structural element, it's possible to have a form with the identified defects. Starting from the results of the visual inspection, it's possible to define the class of attention. In particular, the guidelines are characterized by the presence of 4 classes of attention: structural risk foundation and seismic risk, that are related to the structural characteristic and the structural behavior of the bridge, and the other 2 that are the landslide risk and the flood risk, that are related to the interaction between the area, the characteristics of the area where the bridge was built. The other level are the level 3. There are the structural preliminary assessment of the bridge using simplified approach. And based on the result obtained by the level 3, it's possible to develop the level 4, that is a detailed assessment of the structural safety of the bridge. And finally, the level 5 is the evaluation of the robustness of the road network, but in the current version of this guideline, this level is not yet defined. The approach of this guideline are based on the theory of the risk analysis that is regulated by the combination of 3 fundamental parts, hazard, vulnerability, and exposure, for the evaluation of the level of the class of attention that can be high, medium, medium low, or low. Each class of attention is defined as a function of different parameters, defined as primary parameter and secondary parameter that regulate each part of the risk analysis theory. In fact, it's possible, in this slide, it's possible to see the different parameters that regulate the hazard of the structural foundation class of attention, that are the expected traffic load, the frequency of the commercial vehicles, and the vulnerability that is based on the level of defectiveness obtained from the execution of the visual inspection, and the other are the classic characteristics of the bridge, the static behavior, the length of the span, and the type of materials. The secondary parameter in this case is the degradation speed that is related to the effectiveness level and the period, the construction period of the analyzed bridge, and the design code used, because the evolution of the design code required different type of traffic load. And the third part is the exposure. The parameter are the average daily traffic and the mean span length. Of the presence, the secondary parameter, the presence of the road alternative, and the importance of possible bypassed entity. Considering the seismic class of attention, the hazard is defined from the well-known P-ground value of P-ground acceleration that is obtained from a table of the Italian design code and the related soil classes. The vulnerability is based from the same parameter of the structural foundation risk, the level of defectiveness, the static scheme, the number and length of the spans, and the materials, the type of materials. And the secondary parameters is the use of the system design criteria during the design phase of the bridge, but the seismic action was introduced after the 2003 in the design of structure. The exposure is the same obtained for the structural foundation. Going in more detail, the hazard for the structural foundation risk depends on the maximum permissible mass of vehicles that is defined by 5 classes from A to E. The class A is defined according to the Italian design code requirements. The other classes are related to a percentage of load related to class A. The frequency of transit commercial vehicles can be low, medium, or high, and is defined low if lower than 300 vehicle day, and high if higher than 700 vehicle day. The vulnerability depends on the defective levels, that also defined by the result of the visual inspection as a function of the importance, the rate of the intensity of the identified effects. And the rate of degradation is related to the construction period of the bridge, is divided in three classes: prior to 1945, from 1945 to 1980, and later to 1918, of course. And the design code is related only to the traffic load model. The other are simple characteristic for the bridge presents in the form of the level 0. The exposure is based on the average daily traffic that is obtained by means of specific evaluation of using the data obtained for the management company. And of the average span length is a structural characteristic of the bridge. And by the presence of the alternative routes and by the characteristic of the bypassed entity if present. And while for the seismic risk, the hazard is based on the P-ground value, and this is defined by 5 hazard classes: high, medium, low, and low. And the subsoil category is that is obtained for the execution of special survey or by the design documents. The vulnerability is determined in the same way for the obtained for the structural foundation risk, but focusing the attention of the structural element that govern the seismic response of the analysis structure in as the bearings and the pier, and the possible use of the system design criteria. In this case, it's possible to distinguish two types of bridge designed considering the seismification and designed only to resist to vertical loads. And the other are simple parameters like static behavior, material, and maximum span length. The exposure is the same obtained for the structural foundation risk. These guidelines are applied to a stock of 10 bridges located in northern Italy, as possible to see by this figure, and 5 of these are simply supported span bridge. The other 5 are long span bridge. This is an important aspect for the classification of the safety level, because regulate the static scheme of the analyzed bridge, and 8 of these are realized in reinforced concrete and in pretension reinforced concrete, but the other 2 have the deck made in steel and the pier in reinforced concrete. For the evaluation of the hazard on the structural foundation risk is considered a maximum permissible mass of vehicle equal to as required by the Italian design code, and consequently recorded in class A. In these 2 figures, it's possible to see the frequency of the maximum girder length. That is a small bridge, only one bridge presents span with length about 60 meter and 68 meter, and the other graph represents the frequency of the maximum pierce height. In this case, only one bridge presents pierce with height greater than 50 meter. And for considering the frequency of the transit of commercial vehicle, only 2 of these 10 bridges present high traffic frequency higher than 700 vehicle day. Considering the vulnerability, three of the analyzed bridges are characterized by medium-high defective levels due to the defects identified in the piers in the pre-stressed reinforced concrete beams of the deck. Considering the other aspects, is important to highlight the defects identified in the bearings that regulate not only the vulnerability of this class of attention, but also the vulnerability of the seismic risk. Eight of this bridge are built between the 15 and the 1915 and the 1980. Only two bridges are realized in 2002. There are the two bridges characterized by the steel deck, characterized by important defects related to the corrosion of the steel profile due to the presence of chloride, because they are close to the sea. And all the bridges are characterized by a class B, designed using without considering the seismic action. And the maximum span length of this bridge are greater than 25 meters. This is a threshold to define a long span bridge for this guideline. Considering the exposure, the value of the ADT is obtained from the highway management company. And but while the average span length is medium for 8 of this bridge, and because only 2 bridges are characterized by an average span length greater than 50 meters. For 5 of this bridge is present as alternative routes, and for 7 of the bridge are interested by a bypass identity classified as law. Only one bridge is characterized by interaction with a bypass entity defined as a strategic, is another important road in Sardinia. Considering the seismic risk, the hazard is defined as low because Sardinia is a low seismic area with a peak ground acceleration lower than 0.05 G. For all of the bridge, and 4 of this bridge as characterized by topographic category equal to T1, and only 2 are realized in zone 23 topographic category. The soil class is defined according to Eurocode 8. 7 of the case study are built in area with A soil class, with other 3 sites having soil class equal to B. And the defective level is calculated as the same reported for the structural foundation risk, considering the importance of the defects identified in the bearing that regulate the seismic behavior of the existing bridge. The exposure is the same of the tools obtained of the structural and foundation risk. In this table, it's possible to see the definition of the class of attention, the structural foundation class of attention, the seismic class of attention. And it's possible to see that 2 of these bridges are characterized by high seismic class of attention that is very crazy for a structure located in Sardinia, because we are located in no seismic area. Is only related to the defects, to the extension of the defects identified in the building, and they represent a very critical aspect for the evaluation of the class of attention, because with this is not possible to schedule the correct maintenance intervention, because the priority in this case is the substitution of the bridge, but is not the correct way for the definition of the maintenance intervention. And to conclude, in this work is discussed the application of the new Italian bridge guidelines to 10 bridges located in North Italy, to evaluate the influence of the different parameters for the definition of the safety level of the existing bridge, consider the multi-level approach that characterize this guideline. And for all the considered case study are characterized by structural foundation risk ranging between medium and high, due to the defective level obtained from the visual inspection results. And in the case of seismic risk, some of bridge fall into high class of attention, and this result influenced significantly the definition of the maintenance intervention, due to the conservation of the building, defined as a critical elements for the evaluation of the seismic behavior of the bridge. Okay, that's all. Thank you for your attention.
Thank you so much, Marco. We had some technical problem, but finally we succeeded to follow perfectly. So, there are any questions by the audience? There is no question. I really want to thank all speakers, Mana, Marco, Giovanna, Afrivi. I nominated all of you. And we can close this section, and I will hope to see in another section for, I don't know, for starting a discussion also with other colleagues. And please, Avriki, I'm sorry, my bad pronunciation always, but please give also our hello to Anastasia and Dionysia. And thank you so much. And
we thank you.
Thank you so much, and see you during the conference.
Thank you, Chiara.
Thank you, Chiara. Thank you so much.
You are. Bye. Bye.
Bye.
Bye, everybody.
I don't know the Turkish, so maybe it's better if you stop the conference. Aiuto, purtroppo problemi tecnici. Ciao, grazie, che un lavoro veramente di un anno, poi buttato.
Sì,
La connessione, purtroppo non dipende da noi.
No, certo, ma comunque secondo me non basta la sessione breve.
Lo so, però
o è solo una sessione breve, cioè virtuale,
faremo così,
perché altrimenti è un casino,
Disastro,
un disastro. Cioè uno viene perché si può inserire, cioè se sa che è virtuale, non sa che
ma li faremo così. Va bene, a dopo. Ciao. No, this is not mine. I'm sorry, I'm bringing yours. This is mine. This is yours. This is yours. Bye.
Bye.
Okay, we can go.
Okay, thank you.
I'm sorry, but if I am the chair, I can't give you more time, even if we have time. So I'm sorry, but
Okay, I understand.
it's for others. So please. But the presentation was really good, and you are finished now. You can enjoy the conference.
Yes.
Okay. Okay. See you later.
See you later. Thank
I'll go in my hotel because I'm so tired. So I need just a few minutes to force myself. Okay, bye.
See you. Bye.
Okay.